Hey robotics folks, today what I'd like for you to do is to start playing around more with the VEXcode VR for especially virtual students. If we're in class, we'll do this in class. But here's what I'd like to show you. Look, here's the assignment. There's going to be my video right here, where it's the video coming soon. What I've got is I said, hey, if you haven't already done this, do the paper bridge instant challenge, and I've got a link to that right there, and that'll take you to the page of that. Back it up. Okay. The VEXcode VR is right here. If you click on that in the Draw Your Initials PDF, if you click this, it should give you this. It might give you the option to download it. But there's the instructions for the challenge from the VEX people. It says you're using the Art Canvas Playground, and it's giving you a challenge, which is create an algorithm for each letter of your initials using pen and draw these. That's your level 1. For those of you who are more advanced, you can do your entire name or even your whole first and last name, not just your first name. The helpful hint is that the squares in the art canvas are 20 by 20 millimeters each direction. And you can use the top camera to look down and use the set pen position blocks here to move the pen up and down. So if you haven't used this before, which you may have played with it during our snow week we had, if you haven't, what you got, I just closed a tutorial video. There's a tutorial video that pops up, and there's also more tutorials up here if you need them, if you have questions. And what you've got is, this is like a drag and drop block-based programming system. So you have a robot that you're going to be programming, and it has certain things you can control. For example, there are some drivetrain controls right here. They're all in this sort of same bluish color. There's a magnet you can use. There's a looks, which is how you do it with your pen or you're printing out things. Here's some control stuff. Sensors, if you have sensors. You have operators right here. Variables, and then my blocks. You can make a custom block, which is interesting, and we might pursue that soon. And comments. So drivetrain, that's what you're going to be using for the most part for this assignment. Drivetrain has to do with making the road move forward, backwards, turning it left, turning it right, start and drive, stop driving, how fast you're going, things like that. There's always going to be a when started block. That is the start of your program. So your computer knows, okay, this is where I'm starting. In this workspace, you can drive your blocks out and you can put them anywhere. And they will not be part of your code until you snap that onto the chain here. And I don't know if you heard through my speakers, it makes like a weird clicking noise to sort of signify it's snapped together. You can always drag them apart. You can move that over and it puts it away again. So when you click, and it says here that you're using the Art Canvas Playground. So if I hit Playground over here, it automatically loads up the grid map. And it gives you sort of an overview from the top of what a robot would look like on a grid map. And if I give it some instructions and then hit play, it will go and do whatever I've told it to do. So let's put in drive forward. No, that's not drive forward. Let's do drive forward for 200 millimeters, just see what happens. So that says we're going to drive forward for 200 millimeters. All right. And I guess that's as far as 200 millimeters is on the on this particular grid map. Notice the timer is still going. It's still running the program, but there's nothing else I told it to do. So I can stop it. I can hit play and it will do the same program again, but you're going to start at the same spot that you're currently at. So that's something to know. Like it's gone 200 more millimeters up. If you want it to start from the beginning again, you go to the refresh button here. It looks like a refresh. Click that and it'll put you back at your original starting point. So let's go to Art Canvas, which looks a little bit different. And you're starting in the middle of the canvas. I don't know if that's where you want to be starting, but there it is. I might decide I want to drive left first and then start writing out my name. But just to see how the size is here, 200 millimeters, if I hit play, that's as far as it goes. All right. 200 millimeters. It says that every block here is 20 by 20. So I wonder if I can zoom into this and see better. I don't think I can. But you can kind of squint at. My eyes are bad, and I'm getting older. My eyes are bad. But you can kind of see they're teeny little boxes. So 10 of those boxes is 200 millimeters. So that's why it goes up as far as it does. Okay? Something else to notice, by the way, is when you hit play, it'll highlight the block that's going. So if I had multiple blocks, like if I said turn right 90 degrees, drive forward again, I'm not going to change anything. I'm just going to say turn right 90 degrees, drive forward again, turn right 90 degrees, drive forward again. That should put me back where I started. Turn right 90 degrees. That should make it look like this again. So this is a complete square. It's going to theoretically walk. So here it goes up, to the right, left, to the right, or to the right, it goes to the right, etc., etc. Sorry, I don't know why I said left. But notice it highlights what's happening, it highlights what's happening, it highlights what's happening. So you can kind of see step by step what's going on. And wherever it messes up, if it doesn't do what you want it to do, you can look at the block that's blinking. And, oh, that's not what I wanted it to do. All right, I'm going to get rid of that. I don't need that. So let's say I wanted to do my initials, which is H, R, H. So I might want to drive, hold on, I'm going to turn it 90 degrees left. And I'm going to drive forward until I'm closer to the edge. So if that's about 200, I'm going to go 2, 4, maybe 600 millimeters in that direction. Now it says drive forward. I could also tell it to drive reverse. But if I'm turning it, I'm turning it to the right. Let me turn it to the left. I turn it to the left 90 degrees, so it's going to go to my left. And then it goes 600 millimeters. So let's see what happens. How far that is. Is that far enough? Yep, that'd be good. All right, if I'm going to have it start right in my name, I want it to then turn right 90 degrees, so it's pointing up again. All right, now I want it to start drawing. And if you look over here, it's telling you about this block called Move Robot Pen. And that's in the Looks section. Move Robot Pen down. That's what it's automatically set to. So moving it down will set it down. And then anything it does afterwards, it'll be drawing a line as it moves. Okay? So I'm going to drive. So it'll be turn left, go forward, turn right. So it's now pointing straight up. I'm going to drive forward. And I'll do 800 millimeters and see what happens. So it's going to turn left, drive along, turn right, put its pen down and start going up. So it has now drawn a straight part of my H. All right. Okay. Not bad. When I was doing this in class the other day, I then said, okay, we're going to drive in reverse for 400 millimeters, which should bring it back down to like halfway up the H. Then I can turn right, go across, turn left, go up, and then come back down again. You don't always have to be going forward when you draw, and I think that might be really helpful. Like I could have said, in between these two blocks, I could have put a turn right for 180 degrees, and then I could have told it to drive forward, and it would have done the same exact thing, except there'd be a point where it turns around and drives like forwards down. The same drawing would happen. So for me, like having it turn around is not necessary. There's no need for it to turn around. It's not like it has a sensor I'm trying to tell it to do stuff with on the front of it. This is just, we're going to tell it a path to go to make an H. So I'm not going to worry about the turn right. I'm going to keep it where I had it with going in reverse for 400. So go over, turn, over, turn, start drawing up, come back a little ways, and then I can have it turn right and go across and then continue from there. So I'm going to turn right for 90 degrees. It's really tempting to hit the turn right here, but that's not going to, if you have something for it to move on to, it's not going to, I think it's just going to turn, if it turns, it's going to turn barely. You want it to turn a full 90 degrees. If you guys have had geometry, you know that 90 degrees is a right angle, right? So it goes from facing up to facing right. Okay? I'm going to turn right 90 degrees, and I'm going to drive forward to draw the crossbar of the H, and I'm going to make it only 300 across. That's probably fine. If I'm thinking ahead, I'm going to want it to turn left again to face up, and I'm going to want it to drive forward, and I'm 400 from the top, so let's go 400 again. And then I'm going to want it to drive in reverse, 800, and that should make the complete H, if I'm thinking right. So let me test and see. drive left, yep, turn it right, put the pen down, draw the H, left bar of the H, back it up to the middle, turn right, go over 300, turn left, go up 400, which should be the same height. Yep. Oh. What have I done wrong? I'm going to let it go for a minute. What's going wrong here? What happened? Oh, look, it's run into the wall. Oh, no. Oh, no. Why is it still trying to go? Why is it going? It's drawing a line that way. What's happened? All right. If you're an astute observer, you'll notice I told it to drive forward 400 millimeters, so it's driven up a little bit. Then I said drive forward for 800. I haven't changed that to reverse. Let's see if it works now. All right, it's going up. That's the first bar on the left side of the H, the line on the left. We got it right. Okay, we got to turn left. We got to go up. And now we're turning back around again. That is what I wanted it to do. And it did it. Finally, it did what I wanted it to do. And that's cool. Guess what? I've drawn an H. How exciting is that? I might want this H to be a little wider. Let's say I make a wider H and make it 400 millimeters across. Let's see what that looks like. So you can play around with it. Since it's not a real robot, you're not wasting any battery power. You don't have to pick it up and reset it every time. You don't have to worry about it running off a table or running under a table or picking up dust bunnies and getting clogged wheels or something. You don't have to worry about that. That's the H. That's an H. I wanted the H. Okay. I kind of like the thinner one better. So where's the one that I drive forward and reverse turn? Okay, this one right here. I kind of like that thinner better. All right. At this point, I kind of want it to make another H at some point. I'm going to need another H, right? This is the H code that makes the H the shape that I wanted it. The last time I did it, the one that's slightly thinner. Can I right click and duplicate? Yep, I can. And look at that. I've got that again. So I'm going to have that again. That way I don't have to redo my H. I'm kind of lucky I have 2 letters in my name that are identical, 2 H's. Let me put that back together. Notice again, if I send this on its way, it's only going to do the stuff that's in this chain. It's only going to go from one to the other like that. This over here, it's not going to run because it's not part of my chain. It's not part of my command line code. It's not going to do all that. It will stop once it gets to the bottom of the H again. Yep, and there it is. Stop. So when I want my other H, when I have that positioning figured out, I'll do that. Okay. If I want it to write like the R, my middle initial is R, do I want it to keep drawing that line? I mean, if it was cursive and I had some nice flowing letters, yes, you're going to connect them. But I don't want it to connect. So I'm going to go back down to looks. I'm going to grab the move robot pen block. And I'm going to tell it to move the pen up. So it can go over a little bit, okay? Back to drivetrain. Let's go forward. Let's leave a space of 200. Oh, wait. I don't want to do that. Hold on. I need to turn it right first because it's still facing up. I need to turn it right so it drives over. There we go. Goes over. And then I want it to face up, so I'm going to have it turn left 90 degrees. And at that point, I need it to put the pen back down again to start drawing the R. And the first thing I'm going to do is drive up for 800 millimeters. All right. Let me bring this. Oops, I can't bring it from there. Notice when you pick up a whole bunch, like if you pick up one of these in the middle, it will pick up everything that's below it as well. So if you want to drag the whole chunk, you got to pick the topmost one that you're dragging with you. Okay. All right. So drive forward 800 millimeters. That'll make this next, the R part. Okay. I don't think you can drive in a curve in this code. I know you can in Robot Virtual Worlds, Robot C Virtual Worlds for VEX, which we'll explore when we get there. But this is just an exercise in like planning a route out. So let's do, if I'm going straight up, an R might have like a blocky R would have straight up to the right, down, back over, and then a sort of diagonal R bar at the bottom perhaps. All right. Let's do that. Let's go. The R is going to put me in a weird place, though. Ooh. I might have to do math, and nobody likes math, except me. Actually, that's not true. A lot of people do like math, but... Alright, so I've got my up. I need to turn right. You know what? I need to turn right 9 degrees. Where is that? I need to drive forward and if I have the cross parts of 300, you turn right for 90 degrees. You drive forward for 400. That'll put it back at the mid-level. You need to turn it right for 90 degrees and drive it forward for 300 because that's how far over it was. I'm doing this because I sort of have a picture in my head. If you need to like run it at every step, see where it is, and figure it out like that, then do that. That is okay. So far I have the bottom of, let's see, I've got the H and I should have most of the top part of the R programmed to go. I'm about to sneeze. I might have to pause this. I hate that. Alright, my pen is up. I'm going over. There it goes. R. Turn right, go forward. Turn right, go halfway back down again. Turn right and come back. Alright, and that is where it stops. Okay, I'm going to need to turn it not 90 degrees, but like 90 plus 45 to the left. 90 plus 45 is 135. And then I'm going to want it to go forward. And it's going to be more than 300 this time, but I'm not sure how much more than 300. 400, it's going to be more than 400 because it's got to get back sort of to the bottom. Let's see what happens. Oops. Oops, oops, oops. I didn't reset it, so it was going to do. And since it was facing a different way, it was going to draw it like sideways this time. Alright, here we go. It's going. Right, move over, turn back, put the pen down, and doing an R. R. You know what? Because I've used 400 and 300, 4 and 3 and 5 is a Pythagorean triple, so I need to make this 500, and that'll put me at the right height. Ha! Ah, that's good to know. How do I know that? There's a formula in math where if I take the square of my two legs of a right triangle and add them together, I take the square root, and that's the hypotenuse, the longest side. So that's, yeah, that's math coming into play. When am I ever going to use math in real life? Well, when I'm teaching stuff to kids. There's a lot of times math comes in handy. We were building robots, and we used, I used some trigonometry, and actually it was fun because the kids that I was working with were also in my pre-cal class, and they were like, hey, we're learning how to, I know how to do that. We did that in class. And I was like, yay. It was one of the times I could actually see it happening in real time. Like, I know how to build this part. I know how long the thing has to be because I know math. I know some trigonometry, which is cool. All right, so that's the height I want it to be at. I need to turn left 45 degrees more to be straight along again. So let me do that. I want to stop moving my pen though. So I'm going to stop drawing with the pen. Move it up. And then turn, we're going to go left 45 degrees. 45 degrees is half of the right angle. It's exactly splitting that 90-degree angle in half. So 45 is a great number for perfect diagonals that are as vertical as they are horizontal. It's kind of cool. So we're going to turn left. We're going to drive forward for 200. I like that. And then we're going to turn left again for 90 degrees, which will point us straight up again, at which point we're going to put our pen back down, and we're going to make another H. And there's the H I copied from above. All right, reset. This video is going to be a bit long because I'm allowing this to run its course. If you want to speed up, I should have said this at the beginning, if you want to watch on double time during these parts especially, I should say that when I type up a description for it, I'll do that. Okay, there's the R. And There's an H. HRH are my initials. Now it doesn't look quite right, and it could be because that R doesn't come down as far as I thought it would. But it's okay. I've got an H, an R, and an H. It's neater than my handwriting. And it took less than a minute to make HRH. All right, so I guess think kind of like an Etch-a-Sketch for this. It's like an Etch-a-Sketch in that it's going to draw, you have a bar or a control for going, well, you don't have to think like an Etch-a-Sketch, I guess, but you have what you're controlling in an Etch-a-Sketch, that is the piece that's drawing, and it's always going to draw no matter where it is. But in this case, I guess I can lift it up. So it's not like an Etch-a-Sketch. Not as much as I thought. Okay. If I wanted to make this R rounder, like I could sort of make my, I could make each leg of it a little shorter and then like add a little leg at an angle. So it's kind of like maybe an octagon shape. So if I wanted to go up and edit my R, this is my R in here. Forward for it, that turn 90 degrees. All right. So I would have to add in some steps up here. Let's make it turn right 45 degrees. And then only drive forward. No, let's make it drive up, by the way, 600 or something instead. And then go 200. And then we have to turn right again for 45. Oh, I did it again. I did that sometimes. Then right 45 degrees. And drive forward for, let's see, not 300, but we'll do 200 again. It's going to be a weird shape. It's not going to look quite right. Turn right 45 degrees. We do another 200. So I've got the sort of upright part there. I turn right, I go diagonal, I turn right again, I go across, I turn right again, I go diagonal down. I gotta turn right another 45, and now I'm going straight down. This R business is gonna have to. Let me see what happens for this. Let me see what the shape looks like. Because that might make it look more like a rounded R if I can have more little turns and chunks drawn. Okay, so we're going to go up not quite as far. I'm guessing it's going to stop about here, and then it's going to go over a little ways, and over a little ways, and over a little ways. I don't love it. I wish I had gone up 75 and then did this angles thing, and then maybe had a shallower angle. Not 75, 700. All right, drive 700, 245, and then do like a 150. And it looks like it's going to be really wide because of what I'm doing with the numbers. So let's make it 150 the whole way around. 150, 150. All right, so that'll make it a little bit smaller. I'm going to take these 4 actually and duplicate. So that way I've got... I can't see what I'm doing. Hold on. I'm going to move these guys. Alright, this stuff here is still the downwards bar of the R, so let's see what this does. Now, wouldn't it be cool if I could always just, I know what the H looks like, that's what I want it to do. Hold on. This is a waste of my time. Look what I can do. I can drive, I can take the move forward. Okay, so right here, everything up in here is the H and then moving over. So I'm going to put that on the side real quick. And then I'm going to test what happens with just the R shape. That way I don't have to watch it draw that H every time I'm testing the R shape. It goes up, over, over. Yeah, that's kind of what I was expecting. Make this 200 and it might actually connect again. All in the space of like 15 seconds. It's kind of crazy. All right, and then I can turn it around. Hold on a second. What's this? Oh, that's the H. So let me do this and see what it looks like when I put this same thing. And I want it to stop here. I don't want to worry about doing the other H right now. Okay, refresh. Play it again. It's doing what I wanted it to do. It's looking more rounded and less boxy. And now, hey, look at that. It might go almost low enough. I may have to change that to go like 600 or something to hit the lowest point properly. It's interesting how long it takes to drive. Something with a real robot, the way that they have these things, there's no way to sense like how far it's rolled or anything. For at least not using the Vex parts that I have access to, it doesn't know how far it's gone, how far it's going. So what you do is you tell it a time to go that distance. You say go forward for 5 seconds, go forward for 10 seconds. And if you've got a battery on board, and that's what, it's running off a battery, right? It's not plugged in, it doesn't have a consistent voltage powering it. You're going to get, like, the longer you run that thing, the less it's going to do what you thought it was going to do, because the power is going to go slowly down as the battery drains. And especially when it gets really low, it's not going to barely move at all, and you're going to have to recharge your battery or get another fully charged battery on board again. So that's one thing that's frustrating, I think, for building these robots, is that I don't have a part that tells it how far it's gone. I know that Legos do. Legos have potentiometers that go all the way around, and they'll tell you how many rotations it's gone, how much of a rotation it's gone. You can say go until you've had so many degrees gone, and if you do the math, you can figure out how wide that wheel is, what the circumference is, and you'll know how far to tell it to go to get that wheel to go exactly as far as you want it to go. So that's really cool about Lego, and some of you guys have probably actually played with Legos, worked with Legos before. I would love to get some Legos back here, but I'm not sure if I have the funds for it. Might be one of those things I buy up slowly over time. What the heck? Hang on, what's going on here? Okay, this is the bottom of that. This guy goes here. I think this will do what I wanted it to do. Let's find out. Let's do the whole thing. Okay. Now we can see the finished product where I've changed my R slightly. This video is probably super long, and I apologize. I'll also tell you all that you can probably pause it and stop it whenever you want to, because that's just me working through the H, the R. Look, it's almost as tall, it's almost as wide as it was going to be. It doesn't quite meet, but that's okay. Let's see if it goes down far enough. Might be too far. But look, we're going to have an H. You know what I could do? I could adjust the angle it turns and shorten this leg so that it falls and hits down like as close to directly below there as possible. But I think that's enough for this video. So your initials, whatever they are, think about how you would draw those, what path you would tell it to go on, how far it would turn, and yeah. Y'all have a wonderful day. If you need anything, let me know. Send me an email. Bye.